In the unit of gas laws, there are 6 main gas laws that we will cover: Boyle's law, Charles' law, Guy-Lussac's law, combined gas law, Dalton's law, and finally ideal gas law. This video is going to cover 2, Boyle's law and Charles' law. The first law is Boyle's law. Now what Boyle's law covers, out of the 4 factors of gases we've talked about, is pressure and volume. Notice how the factors we're looking at can vary for pressure and volume, depending on what changes are made to the gas and its state. Under Boyle's law, we're assuming that temperature and amount remain constant. When Boyle developed his equation, he developed something that looks like this. P1 times V1 equals P2 times V2. The ones indicate the original conditions, or initial conditions. Suppose I give you a container that is 25 milliliters with a pressure of 2 atmospheres. That is an example of initial conditions. Now what gas laws do is they look at a change. That's what the 2's represent. So suppose I took this 25 milliliter container and I changed it to 50 milliliters. A sample question could be, what would be the final pressure or changed pressure under this condition? Now before we get into our first example, let's take a look at the units that are involved. With pressure, any units can be used. For instance, we learned that there's units of torr, atmospheres, and kilopascals. Any of these units can be used in the equation so long as they're the same on both sides. So for instance, if you have atmospheres on this side, you must have atmospheres on the other side. Volume is the same way. Any units can be used. For instance, liters and milliliters. So long as they're the same on both sides of the equation, you can use any unit that you want. Now that we know what Boyle's law is and the factors, let's go ahead and now look at a sample problem. Take a moment right now and pause the video in order to write this down in your foldable. When you are done, hit play and we'll work it out together. All right, anytime you get to a gas law question, it is very important to learn how to analyze the problem. Our situation is this. If a volume of 23 liters exerts a pressure of 3.4 atmospheres, how much pressure will be exerted if the volume is changed to 31 liters? That's a lot of numbers and a lot of words. Let's make sure we break it down so we know exactly what we're working with. If a volume of 23 liters, so right away I know that I have a volume, exerts a pressure of 3.4 atmospheres, so now I have a pressure, and since these two go together, I know that this is my V1 and my P1. How much pressure then, so I know I'm solving for another pressure, which must be my P2, will be exerted if the volume is changed to 31 liters. My V2 must be 31 liters. Let's do a quick check and make sure that I have the same units. I have both my volumes in liters, which is good. And since my pressure is in atmospheres, I know my final answer will be in atmospheres as well. Now, as I look at these, I notice that I have 2 volumes and I have 2 pressures, which is meaning we're going to use Boyle's law. Now that I know what equation I'm using, let's go ahead and plug in the numbers where they go. The first one is P1. I know P1 is 3.4 atmospheres. I'm going to times that by my V1, which I know is 23 liters. That is equal to P2, which I'm solving for, times V2, which in this case is 31 liters. Now, since my unit is P2, and that's what I'm solving for, I need to get it by itself. I do so by dividing both sides by 31 liters in order to get it by itself and cancel. On the right side, the 31 liters cancels out, and P2 is now by itself. My answer is now going to come from the calculation that is on the left side. We take 3.4 times 23 divided by 31. The answer I get is approximately 2.5225, and it continues to go. Let's figure out how many sig figs my answer should have. Sig figs are always coming from the lowest amount of sig figs based on the information given in the problem. I was given 23, which has 2 sig figs, 31, which has 2 sig figs, and 3.4, which has 2 sig figs. Out of all of those, 2 sig figs is my lowest, and therefore my final answer is going to be written in 2 as well, which gives me 2.5 atmospheres. Let's go ahead and take a look at another problem. Pause the video and work on this one by yourself on your whiteboards, then hit play to get the answer. All right, analyzing the problem again, I have a volume of 13 liters that exerts a pressure of 76 kilopascals. I know those go together, so I'm going to give them ones. What volume then, so I know I'm solving for volume, would be there if I change the pressure to 134 kilopascals? I know the unit or the equation that I'm using is Boyle's P1V1 equals P2V2. So now let's plug in the information where it goes. My first pressure is 76. My first volume is 13. My second pressure is 134. And my second volume is what I'm solving for. Divide both sides by 134. And I get my volume. Let's take 76 times 13 divided by 134. And my final answer with correct significant figures is 7.4 liters. Make sure your answer is in liters because it was the volume we were solving for. At this time, this is what I would like you to do. Turn to your shoulder partner, either left or right, and decide who is partner 1 and partner 2. Please take 5 seconds to do this. Now that you have your partners, let's take a look at the questions that are on the screen. If you are person 1, then you are responsible for teaching how to do the first problem. Person 1 will teach, and person 2 will write it down on the whiteboard. Then, if you are person 2, your responsibility is to teach the second one, where person 1 will do all the writing. Pause the video, then when everyone is done, hit play. For the first one, your answer should be approximately 2.0 atmospheres. And for the second one, your answer should be approximately 37 pounds per square inch, or psi. Now that we've finished with Boyle's law, now let's take a look at Charles' law. Charles' law is our second gas law. He too is also looking at two factors that can affect a gas, but it's not pressure and volume he was concerned with. Instead, he was concerned with how does volume and temperature relate to one another when pressure and amount is remained constant. The equation that he came up with was V1 divided by T1 equals V2 divided by T2. In other words, my initial volume divided by my initial temperature is equal to my changed volume divided by my changed temperature. Now, as we're looking at these units, let's make sure that we have the right ones. Volume can still be represented in any unit, whether it's liters or milliliters, so long as it's the same on both sides. However, for temperature, it is important to note that it must be in the Kelvin. If you are given a problem that gives you degrees Celsius, you need to convert into Kelvin before you're able to use this equation. Remember, you can get from Celsius to Kelvin by adding 273. Once everyone is ready with this slide, go ahead and hit play and resume. All right, our first problem is this. Hit pause to allow everyone to write this down, then hit play to see it worked out. The situation we're looking at is what would be the temperature of a gas occupying 15 liters if the original volume was 28 liters at a temperature of 298 Kelvin. Right away, my eyes go to this word original. I know that my original volume, or V1, was 28 liters. And the temperature that goes along with it is 298 Kelvin. The question is asking, what would be the temperature, meaning new temperature or changed temperature, if the volume accompanying it was 15 liters? Seeing how the only factors I have are two volumes and two temperatures, I know that the equation I'm going to use is V1 over T1 equals V2 over T2. Now, let's go ahead and plug in the information. My initial volume, or V1, is 28 liters. My initial temperature is 298 Kelvin. Since it's already in Kelvin, I can go ahead and just plug that in to the equation. That's equal to my V2, which is 15 liters, over my T2, which is what I'm solving for. Now what I do is I'm going to cross multiply in order to solve this problem. I'm going to take 15 times 298 and set that equal to 28 times T2. By rewriting this equation, I get the following. 28 T2 is equal to 15 times 298. I divide both sides by 28 liters, and now I'm ready to calculate. My T2 is going to equal 15 times 298 divided by 28. My answer that I get here with correct sig figs is 160 Kelvin. Since my original information was given in Kelvin, I can leave my unit in Kelvin as well. Now let's go ahead and let you try one. Pause the video and allow everyone to try this on their whiteboards, then hit play when you're ready to see the answer worked out. All right, we have a balloon that has a certain volume of 12 liters. And at that 12 liters, the temperature is 25 degrees Celsius. Now, if we cool our temperature to 20 degrees Celsius, the question is asking what would be the new volume? Once again, I see two volumes and two temperatures, so I know I'm going to be working with Charles. Now, if I look at my volumes, I'm in liters, so I know my answer will be in liters, but my temperatures are in degrees Celsius. I cannot use this equation yet because my temperatures are in Celsius. I need to change them to Kelvin. Remember, you just add 273 to get your Kelvin. And so, my initial temperature would be 298 Kelvin, and my final temperature would be 293 Kelvin. Now I can use my equation. I plug in my V1, which is 12 liters, over my T1, which is 298 Kelvin. That is equal to my V2, which is what I'm solving for, over my T2, which is 293 Kelvin. To solve this, I'm going to cross multiply V2 with 298 and 12 with 293. Rewritten, I get 12 liters times 293 Kelvin is equal to 298 Kelvin times V2. Divide both sides by 298 Kelvin to get V2 by itself. And now I calculate. V2 is going to equal 12 times 293 divided by 298. My V2 in this case is approximately, with correct sig figs, 12 liters. Now, with your shoulder partner, turn to the left or to the right and decide who is person 1 and person 2. Take 5 seconds to do this. Now, what I would like you to do is I would like you to solve these problems. Person 1, you are responsible for teaching number 1, while person 2 writes it down. Then person 2, you are responsible for teaching number 2, while person 1 writes it down. Pause the video, then hit play when everyone is ready to have the answers revealed. Let's make sure that we have the setup correct for each one. For the first one, your setup should be 14 liters over 303 Kelvin is equal to V2 over 296 Kelvin. If we take 296 times 14 divided by 303, we get, with the correct number of sig figs, approximately 14 liters for our final answer. Now you might notice how the volumes are practically the same. This is because your degrees are extremely similar, and therefore your volume is extremely similar. This is not an uncommon situation. It can happen a lot. Volume changes can be very, very minimal. Let's look at your second one. For your second one, you should have the following setup. 5.3 liters over 298 Kelvin is equal to 7.2 liters over T2. Now, when I solve for T2, I get approximately 405 Kelvin. However, our original information that it gave us was degrees Celsius. And so since it gave me degrees Celsius to begin with, I want my final answer to be represented in degrees Celsius as well. Since you add 273 to Celsius to get Kelvin, we're going to subtract 273 to get from Kelvin to Celsius. With correct sig figs, I'm going to change that to 130 degrees Celsius. This concludes the video lesson. You are now able to do practice problems with Boyle's law and with Charles' law.